Hi guys, and welcome to our video where I'm going to be outlining the different types of additive manufacturing or 3D printing and how each of these different 3D printers work. Please remember to like our video if you find it useful and to subscribe if you'd like to see more content. Now, as you may or may not be aware, there are many different types of 3D printers available. Because of this, in 2012, the American Society for the Testing of Materials, in their F2792 report, decided to categorize additive manufacturing into 7 different categories. I'm going to go through each of these 7 different categories and walk through how these categories work and how they differ with the aid of some schematics. These schematics are not my own, but I will have the links to these in the description below. Additive manufacturing, or as it's more commonly known, 3D printing, is a relatively new manufacturing method which dates back to around about 1984. As opposed to subtractive manufacturing, where you might start with a block of material and cut away at it or chisel away at it with a CNC machine in order to get your part, additive manufacturing will start off with the build plate being empty and you will add material in a layer by layer fashion in order to build up your part. Each time, the printer will trace out the required shape for each layer of the part. The advantages of additive manufacturing include potentially unlimited design freedom, so as long as your part can fit inside the build volume for the printer, you can potentially print any shape inside that. Additive manufacturing enables fast prototyping, so if you create a part and you want to change it quickly, instead of having to create a whole new mold, you can change your CAD file and press print again. In addition to this, additive manufacturing produces much less waste as it only uses the material required as opposed to chiseling away and producing waste material. And additive manufacturing has got the ability to produce very complex parts. However, there are some disadvantages to additive manufacturing. This can include potentially a lack of materials available. So when we're talking about metals, generally we're going to print with metals which are very easily weldable. In addition to this, additive manufacturing can be very slow. So for example, if we're going to print an aluminium can, this would take in the order of hours to print. However, if we're just going to traditionally press it, it would just take seconds. This leads to a low economy of scale for additive manufacturing. We'll start off with vat photopolymerization, since this was the first additive manufacturing method patented by Chuck Hull in 1984 from Texas. There should now be a schematic for a typical vat photopolymerization printer on the screen. Vat photopolymerization can also be called stereolithography or SLA, and it's from this name that we get our .stl files, which are used across most 3D printers. For a vat photopolymerization printer, we will need a light sensitive resin, and this light sensitive resin will be illuminated with light. Upon illuminating it with light, it will cause a chemical reaction which will cause the resin to solidify very locally, causing one layer. The printer will then either raise or lower the build plate and the new layer will be printed. Typically, vat photopolymerization printers have very messy post-processing, as the part will be encased in the resin, so you need to wash off this resin with alcohol and then cure the part by UV or visible light after it's been printed. The prices for these printers can range from around £200 to into the tens of thousands, making them very good for entry-level or hobbyists. However, as I said, they are quite messy. There should now be some parts which can be printed by SLA or vat photopolymerization printers on the screen. The next additive manufacturing category, which we're going to talk about, is material jetting. Material jetting is the most similar to traditional inkjet printing, which you may be familiar with. Again, there should now be a schematic on the screen. As the print cartridge moves over the print bed, it will eject out droplets. Inside these droplets will be a carrier fluid and the material which is being printed. The carrier fluid will typically evaporate off on contact with the build plate or the preceding layer, leaving behind the material which your part will be made of. Typically, these printers can print waxes, resins and polymers, but not usually metals, and they can range in price from around about £5,000 to a few £100,000. Again, there should be some examples of parts printed by material jetting on the screen now. The next category that we're going to talk about is binder jetting. Now, binder jetting, as opposed to material jetting, is where a binder is printed across a powder bed. Again, the schematic should be on the screen now. So, as this binder moves across the powder bed, it will eject out a binder, which you can think of as a glue, which will bind together the powder in this desired shape for each layer. After one layer has been complete, the build plate will lower by one layer thickness, which is defined by the user, and then fresh powder will be deposited on top of your part, and the process repeated in order to build up your part. Typically, this printing method can print polymers, some ceramics and metals. However, it should be noted that when this technique is printing metals, the parts are generally very porous due to printing on a powder bed, so you can have post-processing such as infiltration in order to fix this. These printers start from around about £50,000 and can go up into the millions of pounds for industrial printers. Again, there should be some example parts on the screen now. Material extrusion is one of the most common types of additive manufacturing or 3D printing, and is probably the one which you will have seen videos of. This is because the printers start from around about £200 upwards. The schematic on the screen should show that a filament is fed in to the print head of the printer, and it's heated up to just above the melting temperature in order to soften the material. It is then extruded through the print head, and the print head will trace out a pattern on the build plate in order to create one layer for your part. Then either the print head will move up by one layer, or the build plate will move down by one layer, and the next layer will be printed, building up your part. Now, these material extrusion printers can print polymers such as PLA or ABS, can also print metal, but when we're talking about printing metal, we're talking about metal shavings which are inside a PLA, so it's not strictly metal. And finally, material extrusion can extrude pastes. So this can enable the printing of food, or even when the printer is scaled up, you can print out concrete and houses can be printed, such as the one on the screen now. I myself have got a Geeetech A10M, so keep a lookout for a next video where I'm going to be reviewing and talking through the upgrades which I have on my Geeetech A10M. Next up, we're going to talk about powder bed fusion. Now, powder bed fusion is split up into two categories, one of which is selective laser sintering, SLS, and the other one is selective laser melting, SLM. Now, the difference between them should be obvious from their names alone, whereas SLS is sintering and SLM is melting. They both work in a similar fashion. So you've got a powder bed covering your build plate, and you'll usually have a laser. This can go from around about 50 watts for SLS up to into the kilowatts for SLM, and this laser will irradiate the powder. So for SLS, it will irradiate the powder to just above its melting temperature to cause the powder to sinter together, and in SLM it will raise the temperature of the powder to well above the melting temperature, causing the powder to melt and fuse together, similar to welding. Typically, SLS can process polymers such as nylon, and SLM can process materials such as titanium, stainless steels, and some aluminium alloys. The price for these printers starts in around about the hundreds of thousands and goes up to the millions per printer. There should be some example parts on the screen now. Another additive manufacturing method is directed energy deposition. Here, focused thermal energy is used to melt together the material as it is being deposited. This is opposed to the powder bed fusion, where the material is already deposited in the form of a powder on the powder bed. Due to the high energies of thermal energy used, typically it is metals that are processed by DED, however ceramics can also be processed. The thermal energy comes from either a high-powered laser, an electron beam, or a plasma arc. The material can be fed in the form of a powder or in the form of a wire feed, and this process is capable of printing parts in situ. What I mean by this is, for example, if you have a turbine blade, you can print on top of that turbine blade without having to remove it from the turbine. Typically, printers start from in the hundreds of thousands up to the millions, and some example parts should be available on the screen now. You should notice that in the as printed condition, these example parts have got quite a poor resolution. What I mean by this is you can quite clearly see the layers. Sheet lamination is the final additive manufacturing category as mentioned by the ASTM in their F2792 article. Now, sheet lamination, while it's not strictly purely additive manufacturing, it's more a hybrid process between subtractive and additive manufacturing. The part is still built in a layer by layer fashion, however there is a subtractive element to this printing process. As you should be able to see from the schematic on the screen now, parts of the sheet are added in and they can be fused together. So if you're using paper, they can be glued together, or if you're using metal, they are typically ultrasonically vibrated in order to melt and fuse together. Here you can use different metals, so you can use a copper and then a steel, a copper, then a steel, or aluminiums, for example. However, once the two sheets have been bonded together, you'll then need to cut out the shape that you need, hence the subtractive element. This can be cut out either by using a laser, or again, if you're printing with paper, you can cut it out with a sharp knife. These printers typically start from around about 10 to 15,000 pounds, and they can go up to hundreds of thousands of pounds, and there should now be some example parts on the screen. Thanks for watching this video. Please do let me know in the comments below which of these 3D printing technologies is your favourite and why, and let me know if you've got any 3D printer yourself and what it is, as I'm always interested in 3D printing. Remember to like the video if you find it useful, and subscribe to our channel if you'd like to see more content like this.